So today we're going to continue our investigation of properties of right triangles. Specifically, we're going to look at what we call 30, 60, 90 triangles, where we have angles that are 30, 60, 90. Our main ideas are to explore the relationships of the side lengths and angle measures, specifically in a 30, 60, 90 triangle. So last class we looked at 45, 45, 90 triangles, and we took a square and cut it diagonally to form a 45, 45, 90 triangle. Today we're going to look at a equilateral triangle that has three 60-degree angles, and so we can form a 30, 60, 90 triangle by cutting a equilateral triangle in half by dropping down a perpendicular bisector, and so we now have a 90-degree angle, a 60-degree angle, and a 30-degree angle. So one of the things that we should be aware of is if on this triangle on the left, I know that the shorter side across from the 30-degree angle, let's say that has a side length of, let's say, 15 units. I know that the hypotenuse of this green triangle on the left, or the side of the equilateral triangle, is going to be 30 because the side on the bottom was just cut in half. And so our equilateral triangle has side lengths of 30 and 30. Again, our focus is on the green triangle on the left, and so we want to be able to find what is the length of the side across from the 60-degree angle. And we're going to talk about how to do that. So, in our notes, you have, like last class, three triangles. We're looking for, in this case, the long leg. I'm going to label all of those as B. So one of the legs of a right triangle. So setting up the Pythagorean theorem for triangle D, we have 2 squared plus B squared equals 4 squared. Solving with the Pythagorean theorem, 4 plus B squared equals 16. And if we continue to solve, B squared equals 12. The directions say to leave our answer in simplest radical form. So to undo a square, we take the square root. 12 is not a perfect square, so if we think about our list of perfect squares, 12 can be rewritten as 4 times 3. The square root of 4 is 2. 3 cannot be square rooted, and so our long leg has a length of 2 square roots of 3. If you continue, if we do one more as an example, letter E, we would have, actually I'm going to do letter F. If we have 3 squared plus B squared equals 6 squared, 9 plus B squared equals 36, continue to solve, and B squared equals 27. To undo a square, we take the square root. Again, 27 is not a perfect square, but we know that 9 times 3 equals 27, and the square root of 9 is 3. The other 3 cannot be square rooted, and so the long leg has a length of 3 square roots of 3. So at this time, I'm going to ask you to pause the video, try letter E on your own, and when you're done, resume the video. So taking a look at letter E, you should have come up with 5 square roots of 3. And so our ultimate goal now is to find patterns. And so if you take a look at the 3 highlighted dimensions, I'd encourage you to see, is there a pattern with those 3 side lengths related back to the original dimensions given that are also highlighted. So please pause the video. Once you think you have the pattern, resume the video and see if you are correct. So taking a look, we can see that there is a connection. The short leg, or the side across from the 30-degree angle, is 2, and we had a value of 2 square roots of 3. The short side across from the 30-degree angle in letter E was 5, and we had 5 square roots of 3. And similarly in question F, 3 and square roots, 3 and then 3 square roots of 3. Which leads us to the following relationship. I have a 30, 60, 90 triangle. We have 3 side lengths. The hypotenuse, which is across from the 90-degree angle. We have the short leg, which is across from the 30-degree angle, and the long leg, which is across from the 60-degree angle. If the short leg has a length of x, we know that the hypotenuse is going to be 2 times x, because if you will recall, this triangle was created from half of an equilateral triangle. Based off of the relationship we shown above, we know that the long leg is the short leg, or x, times the square root of 3. Written out in words, the hypotenuse is 2 times the short leg, and the long leg is the short leg times the square root of 3. So as you can see, in terms of finding the side lengths, the short leg is the key component. If you can identify the length of the short leg, you can find either the hypotenuse or the long leg, and vice versa. So let's look at a couple of examples. So taking a look at question 1, we have the short leg. So that has a length of 8. We know that finding the long leg has a relationship of the short leg times the square root of 3. So the long leg is unknown, the short leg is 8, and so the long leg ends up having a length of 8 square roots of 3. We also know there's a relationship between the short leg and the hypotenuse. The hypotenuse is 2 times the short leg, and so the hypotenuse being unknown, or y, the short leg being 8, 2 times 8 is 16, and so the hypotenuse has a length of 16. At this point in the video, please pause and try number 4. Okay, so you've tried number 4. Taking a look to see if you are correct, we have the short leg. To find the long leg, we know long is the short times the square root of 3. So y equals 1/2 times the square root of 3. You could leave it like that. Many people will write it as the square root of 3 over 2. In terms of finding the hypotenuse, we know there's a connection between the hypotenuse and the short leg. The hypotenuse is 2 times the short leg, and so x equals 2 times 1/2, and so the hypotenuse has a length of 1. Trying question 3, we know the hypotenuse. We do not know the short leg, so we're going to find that first. Again, we know there's a relationship. The hypotenuse is 2 times the short side. The hypotenuse being 20 and the short side being unknown, or y, we can undo multiplication by dividing. And so the length of the short side turns out to be 10. Now that we have the short side, we can continue to find the long side. We know that the long side is equal to the short times the square root of 3. And so if we substitute in, the long side is unknown, the short side was 10, we see that the long side has a length of 10 square roots of 3. So again, at this point in the video, please pause, try question 5. So now that you have tried question 5, hypotenuse is 11, working towards the short side, hypotenuse equals the 2 times the short side, so 11 equals 2x, dividing by 2. The short side has a length of 5.5. We can now use that short side to find the long side. So the long is the short side times the square root of 3. And so y equals 5.5 times the square root of 3. You can leave it like that. Some people will recognize that 5.5 is 11 halves. So they would write that as 11 square roots of 3 over 2. So the last relationship that we're going to look at is what happens if we know the long side. And so looking at question 2, we know the long side, working towards the short side or the short leg. The long leg is the short times the square root of 3. The long leg is 9 square roots of 3. The short side is unknown. So to undo multiplication, we can divide by the square root of 3. And so the short side turns out to be 9. We can then use the short leg to find the hypotenuse. The hypotenuse is 2 times the short side. And so y equals 2 times 9, or 18. And so the hypotenuse has a length of 18. So at this point, again, pause the video and try question 6. With question 6, we know the long side, and so the long side is the short side times the square root of 3. So 12 square roots of 3 equals the short side unknown times the square root of 3. Undo multiplication by dividing. Square roots of 3 cancel out, and so the short side has a length of 12. We can then use that short side to make our way to the hypotenuse, and so doing so, the hypotenuse is 2 times the short leg, and so y equals 2 times 12, and so the hypotenuse ends up having a length of 24. So that is the 30, 60, 90 relationship. We will continue in part 2 to show what happens when we don't have a factor of square root of 3 that cancels out.